Hi guys, we are from sections 11, group X. So today we will present about our micro P assignment projects, group assignment. So I'm Liu Jianxing.
I'm Leo Bung Khai.
I'm David Ong.
Okay, so David Ong, you may present your slide now.
So basically, this is our circuit design, and this is our coding. For the coding, we set a few global variable to handle the user input password, set password. This is the predefined password. This is the password entered by user, and count to check the how many digit password has been entered by user, and the test if equal to 1 if the password is correct, and the door if the door is open or closed, and the trial. So here is the sum uh, function, uh, the predefined function. And for the setup, first of all, we define a draw stat variable, and we set the DDRA is input, and the DDRB and DDRC is output for the 7 segment, and the DDRD is from the PD1, PD2, PD3 is input, and the address is output. And this is the pull out for the limit switch PD3. And here is the sound register for the interrupt. So Liao Bunkai, can you explain it?
Okay. So for GICR, we set it as 0xC0 to enable the interrupt 0 and interrupt 1. So for MCUCR, we set it as 0x07. So for interrupt 1, it will trigger for any logical change, and for interrupt 0, it will be rising edge triggered. Okay, so now I'm going to explain about interrupt zero. So when the keypad is pressed, the DA pin from the keypad encoder will trigger the interrupt zero. So every time the user input a single digit, the interrupt zero will be triggered, and the interrupt zero will check what digit is the user input, and the number will be stored in array input pass. After that, the number will also be displayed at the 7 segment display. So when all 4 digits are fully inserted, it will proceed with the checking subroutine function. I will pass my mic to Liu to explain about interrupt one.
Okay, so I'm Liu. So basically the interrupt one is the limit switch. So basically this limit switch is when we push the limit switch, which means the door of the safety box is open. So when the door is open, so we will try to set the port D, the PD4, the internal light up, and then set the variable door equal to 1. Okay, so for next I will pass to David again.
Uh, so after the setup of the interrupt, so we are going to enable the global interrupt by this condition, pin D equal to 0, 1, 0, 0, 1, 1, 0, 0, to avoid any false trigger at the beginning. So after enable the global interrupt, we are going into the main coding loops or one loops. Count equal to 4 if user enter 4-digit password, fully enter. Then it will proceed with the checking password. So Liao will explain it.
Okay, so for the checking password function, so first we will set the variable state equal to 0. So we will check all 4 digits of password. If the all the password are correct, the state will equal to 4. But if there is wrong in the password key in, the state will not be 4. So when state equal to 4, test will be set to 1 and send back to the main coding. And if state is not equal to 4, the test is equal to 0 and it will be continue to the wrong password function. So for the wrong password, the buzzer will hide for 1 second for 3 times, and the 77 will blink for 3 times also. After that, the array input pass will be cleared, and our trial will +1, and the test variable will become 0. So now I'm going to pass back to David.
Okay, like what as Liao Bunkai said, if the password is correct, the test will be 1. So it will going into this if condition for the unlock sequence. So Liu,
Okay, so I'm Liu. So for this unlock sequence is basically is try to turn off the red LED and turn on the green LED, which means this system is on already. So it will try to rotate the servo motor to 90 degrees, and then by using the pulse wave 8 millisecond, and then it will try to turn on the buzzer to sound for 1 second. Yeah. So I pass back to David again.
so after the unlock sequence, we need to reset the password so that when it will not be unlocked for the next loop. So for the reset password, uh, Liu,
Okay,
continue.
so basically this reset password is when the system is detect the password is correct. So we will try to, after that, if detect the system the password is correct, so the password will reset it, and then will reset the input array to become all the 0, and then reset the test variable to equal to 0.
Okay, then after reset the password, the door will remain open for 5 seconds.
Okay, so basically we're using the delay 5 seconds. Okay, so basically we're using the 4 functions. Okay, if door equal to 0, so delay one timer 1 second, we are using the timer 1. So okay, so after we doing the calculations, so you can see that the prescaler 64 is the best. We choose prescaler 64 because because it has the best resolutions. Okay, so basically we set all the needed requirement in TC1 hash TC1 equal to 0, and then we set the number, which is the CNT equal to 62499, and then TCR1A equal to 0, and then TCR1B we set it become the CTC mode, and then prescaler 64. So basically we loop the while loop, and then stop the timer, and then so on the clear, also the TIFR. Yeah, so I'll pass back to David again.
So the reason we need to wait for 5 seconds before, then it will automatically lock back the door for safety purpose. For example, if the user enter the password, it will then he or she forgot to open the door, then the system will lock the door for safety purpose. So for the lock sequence, Liu will continue to explain about it.
Okay, so for the lock sequence, which mean we try to lock the systems. Okay, so basically we set the motor turn off to the original directions with the 0, and then we try to turn off the green LED, and then turn on the red LED, which means the system is locked again. Okay, so the buzzer will sound for 1 second or so. Okay, so and then we will try to turn off the internal LED, which is the blue LED. Yeah, so that's all from these functions. So I will pass back to David again.
So after the lock sequence, the door step will be set equal to 0 to tell the microcontroller that the door is locked. Then the trial will be reset to 0. For example, if user open the door in this case, the door state, first of all, the door is closed. So if the door set equal to 0, then the door set will become 1, because when user open the door, it will trigger the interrupt 1 for the first time, and then if user close the door, it will trigger the interrupt 1 door for the second time. So in that moment, the door state is 1, so it will proceed with the else condition, which is delay for 1 second, and then proceed with the lock sequence and reset the door state. For example, if user enter the wrong password for 5 times, so this for loop will continue for 60 times. This is the delay timer 1 second, which means it will delay 60 seconds. In this 60 seconds, user cannot enter anything. Even though the correct password, it will not functioning. It will remain locked position. So user need to wait for 60 seconds to pass before it can enter the new password for it to be unlocked. Then this loop will be continued forever. So let's get into the practical demonstration. For the circuit design, we consist of one ATmega32 and the keypad encoder and a 3x4 keypad matrix. This red LED and green LED to indicate the safety box is in lock or unlock condition. And this is the internal spotlight to light up everything inside the box, so that the user can see and take things easily from the box. And this is the buzzer, and this is the servo motor to lock the door, and this is the limit switch to check if the user open or closing the door. This is the 7-segment display, and we are using the 4511 BCD to 7-segment converter to load and to hold the value. Okay, so first of all, the correct password is 1024. For example, if I enter 1024, the green LED turn on to indicate it's unlocked, and the servo motor will turn 90 degrees to unlock the door. As you can see, after the 5 seconds, it will proceed with the lock sequence for safety purpose, so that because the user forgot to open the door, so it will lock back. For example, now I'm opening the door, so immediately the internal spotlight will turn on for the user to see everything inside it, and then the door will remain unlocked until the user closing the door. So it will, as you can see, is after 5 seconds, it still remain unlocked. For example, if user close the door, the buzzer will sound and the red LED will light up to indicate it's in lock position. The another scenario is when user enter the password wrongly for more than 5 times. So the buzzer will sound for 3 times and it will blink. So already entered the wrong password for 5 times. So as you can see, nothing will happen right here. So we need to wait for 1 minute, 60 seconds to pass. So after pass for 60 seconds, for example, user enter again the correct password, then it will unlock as usual. After 5 seconds, it will locks back. So for another situation is, for example, user enter 3 passwords, suddenly it hits this symbol, so it will reset everything equal to 0, same as this symbol, it will reset. So these two symbol is function like reset. That's all from us. Thank you.